Assalamualaikum and hello to all my friends. Uh, Now I will continue the example 4.5. The question is determine the fraction of steam extracted from the turbine and the thermal efficiency of the cycle. So we need to determine Y value as state number 6 and thermal efficiency for the ideal regenerative Rankine cycle. From the data given, P4 equal to P5 equal to 15 megapascal, T5 600 degrees Celsius, P1 equal to P7 10 kilopascal, P6 equal to P3 equal to P2 1.2 megapascal. So this is the thermal efficiency formula. So we move to the step 1. P1 equal to 10 kilopascal. The phase is saturated liquid. So H1 and V1 we can determine from the saturated water pressure table. We find 10 kilopascal first, so we can get H1 and H1 and V1 from the table. So we move to state 2. P2 equal to 1.2 megapascal, S2 equal to S1. Because P2 is less than 5 megapascal, so we need to use estimation because data is not available in the table. So the phase is compressed liquid. This is formula W pump 1 in equal to V1 bracket P2 minus P1 equal to H2 minus H1. We get 1.2 kilojoule per kilogram. So the answer, the value of H2 is 193.03. So we move to state 3. P3 equal to 1.2 megapascal. The phase is saturated liquid. So we need to find H3, V3 and S3. First we find 1.2 megapascal. So we can get VF, HF and SF. Next we move to state 4. P4 equal to 15 megapascal. S4 equal to S3 equal to 2.2166. Because P4 is greater than 5 megapascal, so we need to use compressed liquid table. The phase is in compressed liquid. So to determine H4 from the table, so H4 we need to determine using interpolation. So we get 0.6 kilojoule per kilogram. For the alternative, to get few error percentage, we can use this formula. W pump 2 in equal to V3. P4 minus P3 equal to H4 minus H3. So we get 814.382 kilojoule per kilogram. So we move to state 5. State 5, P5 equal to 15 megapascal, T5 equal to 600 degrees Celsius. The phase is in superheated vapor. So H5 and S5 we can determine from the superheated water table. So first we find the temperature. The temperature we get 600. So we find the column with P equal to 15 megapascal, so we can get H and S. So next we move to state 6, sorry. P6 equal to 1.2 megapascal. X6 equal to S5, 6.6776. Because S6 is greater than SG at 1.2 megapascal, we can find the SG in the saturated water pressure table. We find the pressure first, 1.2 megapascal. So we get the SG is 6.5233. Because S6 is greater than SG at 1.2 megapascal, so the phase is in superheated vapor. So we need to use superheated water table. After that, to determine H6, we need to use interpolation. Then we get 2859.54 kilojoule per kilogram. Next, we move to state 7. State 7, P7 equal to 10 kilopascal, S7 equal to S6 equal to 6.6776. S7 is in between SF at 10 kilopascal and SG at 10 kilopascal. From this, we get phase is in saturated mixture. So we need to insert SF at 10 kilopascal and SFG at 10 kilopascal into this equation. We can get both of these from the saturated water pressure table. After we insert the value, we get X7 equal to 80.37% or 0.8037. So we need to find H7. H7 equal to HF at 10 kilopascal plus X7 HFG at 10 kilopascal. We can get HF and HFG from the saturated water pressure table. After we insert the value and X7 from this, we get the value of H7 to 115.0 kilojoule per kilogram. Next, we move to the calculated data. So we list down all H1 until H7 that we get before this. So we need to find the fraction of steam Y. Fraction of steam Y equal to Y6. E in equal to E out. This is summation m dot h equal to summation m dot h in and out. Summation in m dot h equal to summation out m dot h. In this diagram, open feed water heater. This is the pressure at steam Y, at y6, at y2, at y1 and y1. So we make the equation m6 h6 plus m2 h2 equal to m3 h3. M6 M6, M2 and M3, all of this uh, we need to over with the M boiler. M boiler is M5. So we get this equation. From this equation, M we know that M dot 6 over M dot 5 equal to Y. M dot 2 over M dot 5 equal to 1 minus Y. M dot 3 over M dot 5 equal to 1. So we get this equation. Then we need to find Y. Y is, we need to find fraction of term Y and Y6. So we get the answer 22.71%. Then we move to the next question. We need to find the thermal efficiency. Qin is equal H5 minus H4. We get 2776.3 kilojoule per kilogram. Then we find Q out, 1 minus Y times H7 minus H1. We get 1486.42 kilojoule per kilogram. To find thermal efficiency, we substitute Q in and Q out from this formula. So we get the answer 46.46%. That's all from me. Thank you.